All right, this video is going to talk about 3.5 and how to use tree diagrams and Venn diagrams for probability. So a tree diagram is a way to organize data with frequencies or probabilities visually. And it's called a tree because it connects things using branches. And each set of branches needs to add up to 1 or 100%. They can be vertical like this one, or sometimes they'll be sideways and look like this. As you move down the tree, you multiply the probabilities because they're and. You're saying this happens and this happens, so you multiply. And then if you're combining probabilities going this way, you're going to add because it's one or the other. So let's look at this example. In an urn, there's 11 balls. 3 balls are red and 8 balls are blue. So the 8B stands for the 8 blue balls and the 3 red stands for the 3 red balls. Draw 2 balls one at a time with replacement. So with replacement makes it independent because you're going to put the ball back every time. This tree diagram using frequencies, so that's the amount of balls, shows all the possible outcomes. The first set of branches represents the first draw. So this is the first draw. The second set of branches is the second draw. So you put it back in, and then you get a second draw. Each of the outcomes is distinct. In fact, we can list each red ball as red 1, red 2, red 3. Each blue ball is blue 1, blue 2, blue 3, so on. Then the 9 outcomes would be red 1, red 1, red 1, red 2, red 1, red 3, red 2, red 1, and so on. The other outcomes are similar. There's a total of 11 balls in the urn. Draw 2 balls one at a time. There are 11 times 11 outcomes because you have 11 from the first draw, 11 from the second draw. 11 times 11 is 121 outcomes. That's the size of the sample space. List the 24 blue, then red outcomes. So you could have blue 1 and then red 1, blue 1 and red 2, or blue 1 and red 3. So those are all the things you could get if you picked blue 1 first. If you picked blue 2 first, you get blue 2, red 1, blue 2, red 2, blue 2, red 3, blue 2, red 3. If you got blue 3, you get blue 3, red 1, blue 3, red 2, blue 3, red 3. Then blue 4, red 1, blue 4, red 2, blue 4, red 3, blue 5, red 1, blue 5, red 2, blue 5, red 3, blue 6, red 1, blue 6, red 2, blue 6, red 3, blue 7, red 1, blue 7, red 2, blue 7, red 3, blue 8, red 1, blue 8, red 2, or blue 8, red 3. So those are all the groupings of picking a blue ball first and then a red ball second. And then 8 times 3 is 24, and I have 24 listed there. So that's what it means when it says list all the possibilities. Then B, using the tree diagram, calculate the probability of red, red. So up here, the first red, we have a chance of 3. The second red, we have a chance of 3. So red times red, 3 times 3 is 9. Out of the 121 total. So it'd be 9 out of 121. We also, if we did it as probabilities, this is 3 out of 11. 3 out of 11. 3 times 3 is 9. 11 times 11 is 121. So now let's look at C. Using the tree diagram, calculate RB or BR. So if we look over here, RB is right here, 24. So that's 24 out of 121. Or is plus. So BR is 24 out of 121. Are there any that are both? No. There's no BR and RB. So we would just add those together. 24 plus 24 is 48. So we get 48 out of 121. Good. Using the tree diagram, calculate R on the first draw and B on the second draw. So R on the first draw is here, B on the second draw is here, and is multiply. So 3 times 8 is 24. So if we multiplied, 3 over 11 times 8 over 11 gives us 24 over 121, which we can double check right here. The totals will not always be there for you. So using the tree diagram, R on the second draw, given B on the first draw. So R, given B on the first draw. So R on the second draw, blank R, given B on the first draw. Okay, so the both would be BR. So BR is this one, 24. B on the first draw was 8. Okay, here's how I'm going to do it so it's not as weird. R on the second draw, B on the first draw is this right here. If we wanted to do that, we would do 3 times 8. Because R on the second was 3 out of 11. B on the first was 8 out of 11. So that's the top. And then on the bottom, B on the first was 8 out of 11. Hopefully that makes a little more sense. Because and we said was multiplying, and up here we knew we could just multiply. They're mutually exclusive because none of them overlap. So B on the first is this, 8 out of 11. R on the second is this, 3 out of 11. So on the top we can just multiply them. The bottom is our given, which is B on the first. So that's 8 out of 11. Now, when you have the same thing on the top and bottom of a fraction, it just cancels out. So this simplifies to 3 over 11. So that's one way to do this. Using the tree diagram, calculate BB. So B on the first, 8 out of 11. B on the second, 8 out of 11. 8 times 8 is 64. 11 times 11 is 121. All right. Using the tree diagram, calculate B on the second, given R on the first. So if we use our little table here, B on the second, given R on the first. So R on the first, B on the second is this. We just followed the path. So that would be 8 out of 11. R on the first is 3 out of 11. So that's the top. Given R on the first, that was 3 out of 11. These are going to cancel. So our probability is 8 out of 11. Hopefully that made sense. And you can do the U-try, pause the video, and then check the answer when you're ready. Okay, in a standard deck, there's 52 cards. 12 are face cards, 40 are not face cards. Draw 2 cards, one at a time with replacement. All are shown. Calculate probability, face card, face card. So the first face card is 12 out of 52. The second face card is 12 out of 52. So 12 times 12 is 144. 52 times 52 is 2704. And for what we're doing, that's fine for an answer. All right, let's go to the next example. Enter as 3 red marbles and 8 blue marbles. Draw 2 marbles one at a time, this time without replacement. So this time we're going to use probabilities instead of frequencies to make our life a little easier. The probabilities are out of 11. But then we're not putting the marble back. So if I take out a blue marble, now I only have 7 out of 10 on the second pick, and 3 out of 10 for red. If I pick a red the first time, the blue stays 8, but the red goes down. Let's change my screen back here. Notice when I go down the bars, 8 over 11 times 7 over 10. 8 times 7 is 56. 11 times 10 is 110. So as I multiply down the branches, I get blue is 56 over 10. Blue, red, 8 times 3 is 24. 24 over 110. Red, blue, 24 over 110. Red, 6 over 110. So going down the branches, the probabilities are already calculated on this one. If they're not already calculated for you, you can just multiply. So using that, let's see what questions are asked. Probability of red. Oops, that's right here, 6 over 110. Probability of red, blue, or blue, red. So this one, they already gave me red, blue. They said 3/11 times 8/10. So let's do blue, red. Blue is 8/11. Then red would be 3/10. If you multiply those together, you get 24 over 110 plus 24 over 110, which gives us 48 over 110. All right. Now let's look at this. Probability of red on second given blue on first. So blue on first is 8 over 11. And red on second would be 3 over 10. So that's the top of our fraction. Divided by the given. So divided by blue on first. This is going to cancel. So we get 3/10. Okay, let's look at D. Red on first and blue on second, which is RB. We have that right here. 24 over 110. E is BB. That's right here. 56 over 110. And then B on second, given R on first. So R on first is 3 over 11. And B on second is 8 over 10. Given R on first, we just said was 3 over 11. Those are going to cancel, so we get 8/10. You do the U-try, pause the video, and start it again when you're ready to check your answer. Okay, table's all filled out. FN or NF. So FN is 480 out of 2652. And F is 480 out of 2652. There's no things that are combined. So 480 plus 480 is 960. So that is the answer. Probability of N given F. So the probability of N given that you got an F. Let's see. Probability of N given that you got F first. So F first is 12 out of 52. And then N after that is 40 out of 51. And then probability that you had F first was 12 out of 52. Those are going to cancel. So 40 out of 51. Okay. At most one face card. So this one's a little bit different. So let's see. This face card has two. Face card, face card. This one here has one face card. This one has one face card. And this one has 0 face cards. So at most one face card is all of these together. So you could get Fn, 480 over 2652, or NF, 480 over 2652, or NN, no face cards, 1560 over 2652. Or means add, and then there's nothing that's both. So if we add those up, 480 plus 480 plus 1560, I get 2520 over 2652. Okay. And then D is at least one face card. Same idea, but we want all but the 0. So we would add FF plus FN plus NF. So 132 plus 480 plus 480 is 1092 over 2652. All right, let's look at another example. Litter of kittens is available for adoption. They have 4 tabby cats and 5 black cats. Family comes in and randomly selects 2 kittens without replacement. What is the probability that both kittens are tabby? So that would be tabby, tabby. So we have 4/9 and 3/8. 4/9 times 3/8. We're going to go down, so we multiply. 4 times 3 is 12. 9 times 8 is 72. What is the probability that one kitten is each coloring? So tabby, tabby's the same. That's not helpful. Tabby, black, those are different. Black, tabby, those are different. Black, black, not helpful. So tabby, black would be 4/9 times 5/8. 4 times 5 is 20. 9 times 8 is 72. Black, tabby, 4 times 5 is 20, 5 times 4, and 7 times 8 is 72. So we have tabby black or black tabby. So 40 out of 72. And then what is the probability that a tabby is chosen as the second? So we said this was 12 out of 72. So this has a tabby second, and this has a tabby second, because they both have T's as the second letter. So we would, let me keep reading. What is the probability that a tabby is chosen the second when the black was chosen first? So black tabby would be just this one right here, BT. So 20 out of 72. And then what is the probability of choosing 2 kittens of the same color? So that's tabby, tabby, or black, black. And so black, black is 5 times 4, which is 32 out of 72. So 12 out of 72 plus 32 out of 72 is going to be, 5 times 4 is 20, not 32. So this, I pre-added. Okay, 20 plus 12 is 32. So 32 out of 72. So lots of different ways to use tree diagrams. Now, let's check out Venn diagrams. So Venn diagrams is another visual representation with circles and a box. Overlapping places are the and So the box is your whole sample space. Each circle is an event. Your overlap is your and. So that's the and in here. And then the or is anything in both circles. So that's the or. Okay? So that's a super quick overall thing. Now let's do a problem. So an experiment has outcomes 1, 2, 3 to 12. So 1 through 12. And each outcome has an equal chance. So A is 1 through 6. B is 6 through 9. Draw a Venn diagram. So we're going to have a box with A and B. Anything that's both is in the middle, so that's 6. Just A goes in the A circle, but not the overlap. So 1, 2, 3, 4, 5. Anything that's just B goes in the B circle, but not the overlap. 7, 8, 9. And then anything that's not A or B, but still is a thing, goes in the box. So 10, 11, and 12. Those are still in our sample, but not in A or B. So there's our Venn diagram. Now, A and B is the overlap. So that would just be 6. A or B is everything in the whole circle area. So A or B is 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 11, and 12 aren't in the circles, so they're not in either. So you try 3, pause the video, and then come back when you're ready to check. Okay, so we know we have a Venn diagram. We know we have 2 circles with a C and a P. So green, blue, purple, red, yellow, blue. The only thing that's the same is blue. So we're going to put blue in here. That's the same. C also has green and purple. P also has red and yellow. Black we haven't written anywhere yet. White we haven't written anywhere yet. Red we have. Orange we have not. Yellow we have. Green we have. Blue we have. And purple we have. Okay. C and P is the overlap. So that's blue. A or P, that's supposed to say C. C or P is everything in the circle. So green, purple, blue, red, and yellow. All right, let's look at another one. Flip 2 fair coins. A is tails on the first coin. B is tails on the second coin. Then A would be tails, tails, and tails, heads. B would be tails, tails, and heads, tails. So A and B. So I'm going to do the Venn diagram first. So anything that's the same. So tails, 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 tails. A also has tails, heads. B also has heads, tails. And then if you're flipping 2 coins, you can get tails, 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 heads, heads, tails, or heads, heads. So we've marked this one, we've marked this one, we've marked this one, and we haven't marked heads, heads. So that's missing. So there's our Venn diagram. So A and B is tails, tails. A or B is that whole thing. So tails, heads, tails, 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 or heads, tails should be the last one. heads, tails. A nor B. So nor means neither, so it's not in either circle. So that would be heads, heads. That's what we wrote over here by itself. And then I already made the Venn diagram. Now you could do those in any order, whatever makes your life easier. I just like the visual. Some people would prefer to do the other things and then make the visual. So when you do the you try, you do it in the order that works for you. Pause the video, answer the question, come back and check when you're ready. All right, so 6-sided dice. So we have 1, 2, 3, 4, 5, 6. That's my sample space. A is prime. So 2 is prime, 3 is prime, 5 is prime. B is odd. 1 is odd, 3 is odd, 5 is odd. A, 2, 3, 5. B, 3 is 5. Well, that's silly. Odd number of dots is rolled. So, even though I wrote this over here, I'm going to go with what I put in the problem. So we'll just go with that. A, B. So, in both, we have 3 and 5. In just A, we have 2. In B, there's nothing that's not also in A, but we haven't written 1, 2, 3, 4, or 6. So, technically 1 should be in B, but it's not listed here, so we're going to go with that. A and B, 3 and 5. A or B, 1, 2, 3, not 1, 2, 3, 5. Neither A nor B, 1, 4, oh, I'm going to do this in the same color. 1, 4, 6, and then here's your Venn diagram. Now, if you had put 1 here instead of here, and put 1 here instead of here, it would be right because technically 1 is an odd number, and you would have just said, oh, hey, there was a misprint here. So I would not mark that wrong if you had done that. But if you had just gone by what was defined, that's also right. So either is fine if you understand why the difference is there. Okay, example 6. 40% of students at a local college belong to a club. So probability of club is 40%. 50% work part-time. Probability of part-time is 50%. 5% of the students is both. 5% is both. Draw a Venn diagram. So Venn diagram, club, part-time. 5% is both. Now for the club, that whole circle has to add up to 40%. So if I already have 5, then 35 has to go out here because the whole circle has to add up to 40. Same thing for part-time. If the whole part-time circle has to add up to 50, and I already have 5, then this would be 45. Because the whole circle adds up to 50. Now, if I add those together, 35 plus 5 plus 45, I get 85. The whole box has to add up to 100. So 100 minus 85 is 15. So that means there are 15% of students that don't do either. So we're going to put 15 on the outside. Now we can answer the questions based on this Venn diagram. Student is selected at random. Find the probability they belong to a club. It doesn't say only a club, so we want club total. So that's 40%. Student is selected at random. Find the probability they work part-time. It doesn't say only, so we do part-time total, 50%. Find the probability they belong to a club and part-time. So club and part-time, that's the overlap, that's 5%. If a student is selected at random, find the probability they belong to a club given they work part-time. So club given part-time. So on top, you put club and part-time. So that's your 5%. On the bottom, you put part-time, which we said was 50%. And then we divide those. 0.05 divided by 0.5 is 0.1 or 10%. All right. Now, if a student selected at random, find the probability they do the club or part-time. So probability of club is 0.4 plus probability of part-time is 0.5 minus the probability of both club and part-time, which is 0.05. So 0.4 plus 0.5 minus 0.05 is 0.85. So mathematically, we get 0.85, which is the same thing we got when we added those three up. Hopefully that makes sense. So pause the video and see if you can do the U-try. All right, 50% of workers have a second job. 25 have a spouse who also works. 5% work a second job and have a spouse who works. Draw a Venn diagram. So 5% go in the middle. 50%, so 50 minus 5 is 45. 25 have a spouse, so 25 minus 5 is 45. Nope, 20. Add those up and you get 70. So that means there's 30 out here. Oh, so this would be W, not. Okay. So there is the Venn diagram. That's all it wanted. Okay. So over last example. A person with type O blood and a negative Rh factor can donate blood to any person with any blood type. 4% of African Americans have type O blood and a negative Rh factor. So, and, right here, O and negative is 0.04, 4%. 5 to 10% of African Americans have the Rh factor. And 51% have type O blood. Draw a Venn diagram to represent this situation. So, here's my Venn diagram. Here is my O. Here is my Rh negative. Here is my 4%. Now, we know it's 5 to 10%. We don't know exactly, so we're going to find an average here. So 5 to 10, if we add that together, we get 15. So somewhere in the middle, 15 divided by 2 is 7.5. So we're going to say 7.5% of people have R blood. Is that fair? Okay, we're going to go with that because 5%, so this is an average. So we're going to say point R is 0.075. So if we already have 0.04, 0.075 minus 0.04 is 0.035. We know 51% have type O blood. So 0.51 minus 0.04 is 0.47. Or is adding all of these up. So 0.47 plus 0.04 plus 0.035 is 0.545. So sometimes you can work backwards given what you know. And then when you're given a range, you just find the middle of that range and go with it. Now, If we knew this, what would be left? So if 0.545 is there, we would do 1 minus 0.545, and we would get 0.455 for people who don't have O or RH negative. That is the end of 3.5. Let me know if you have any questions.